Good morning everyone and welcome to CTPM's first webinar of 2013. We hope you had a great Christmas and if lucky enough a great break. Today's topic is how do we get equipment and people to work perfectly, and the session will run for half an hour. My name is Samantha Rowan and I am the Marketing and Operations Manager here at CTPM and I will be your chairperson today. Our presenter today is Ross Kennedy. Ross is the President of CTPM Australasia and heads up a team of CI specialists based in Australia, New Zealand, Indonesia and Thailand. After 20 years of operations experience, followed by 5 years of international consulting experience, he established CTPM with several colleagues in 1996. Ross has been actively involved with Lean since 1985 and the application of TPM since 1990. He has conducted over 200 public workshops and presented over 50 papers on TPM and Lean. He is recognised as Australasia's leading authority on TPM and TPM Cubed. Now before we get started, I'll just cover a couple of useful hints for people who have not used GoToWebinar before. Here we have a control panel with a variety of functions. This button, View in Window Mode, allows you to change your view. We have the Raise the Hands button, but due to the amount of people joining us today, we'll be not using this function. Instead, if you'd like to ask any questions, please type them in the control panel box provided. We'll attempt to answer all questions at the end of the session. However, if we do run out of time, we will send out a question and answer sheet via email, so no one's questions will go unanswered. If you don't want to write any questions, you can hide your control panel by simply pressing this button here, and this will leave you with a little bar instead of a big control panel. To leave the webinar, simply go to File and press Exit Leave Webinar. Throughout the webinar, we'll also be having some interactive polls. So when a poll appears on your screen, simply select one of the answers and press Submit. So other than that, I hope you enjoy our webinar today, and I will now pass you on to Ross.
Good morning everyone. Welcome to the webinar on how do we get equipment and people to work perfectly. And I've added a little bit to the bottom of the title, at the lowest possible cost. So I think at this current economic climate, we're all looking for ways to achieve significant cost reductions within our business. The webinar will cover the following. Myths and realities of operator impact on getting equipment and people working perfectly, the maintenance impact and the planning and scheduling impact on getting equipment and people working perfectly at the lowest possible cost. Now to set the scene, I thought I'd just talk about three brief topics about equipment failure, the cause of equipment failure, approaches to address equipment failure, and understanding the nature of equipment failure. Because if we don't understand about equipment failure, it is very hard for us to really, I guess, get our head around how do we get our equipment to run perfectly. So the first one is the causes of equipment failure. We've created this slide to help people understand that when something fails, and we're talking about your machinery in the plant, which is often entails a lot of mechanical type componentry. Often equipment doesn't just stop. There's often some signs beforehand. We often see in plants where there is poor performance. In other words, the equipment is not running at the correct speed, or the equipment is not producing the product to the right tolerance. Now often before that starts to happen, there'll be further signs. Things like getting vibration in the equipment, noise, heat or fumes. Now you notice we have the numbers 1 and 2. 1 represents natural deterioration, because we see deterioration can be caused by two reasons. One, natural, in other words, equipment reaches its natural life, or the component reaches its natural life. Whereas in the other scenario, the component has early or accelerated deterioration. In other words, it fails earlier than we would expect it to. For example, we might put a pump into our plant We expect the pump to run for, say, 5 years. After 2 years, the seals might start leaking and the pump may not be performing to requirements. Now, that's an example of early or accelerated deterioration. And then the next question we ask is, why does early and accelerated deterioration occur? And I guess all our research has shown that it can be put down to two factors. One, either lack of understanding or a lack of desire to care in relation to the equipment. Now, this can relate to the way we've designed the equipment. It could be the way we've gone and purchased the equipment. In other words, we've gone and bought a cheap component, the way we've installed it, the way we operate it, and most importantly, the way we maintain it. And I guess the learning from all that is, if we think about what causes early accelerated deterioration, it can be influenced by all the people in our business. Now, we have to look at how do we address this lack of understanding or desire to care. First of all, we need to understand or see examples of it. If I use an operator as an example, who's ever seen an operator grab a compressed air line and blow down their equipment? They might be blowing it down to clean it, but they're using the compressed air all over the equipment. Now, some people think, well, that's reasonable practice. I guess our learning has been is when you start using compressed equipment anywhere near where there are seals, for example, motors, gearboxes, and electrical equipment, you can blow minute pieces of dust particles into the equipment, which will then cause accelerated deterioration. So when we go and talk to operators and say, why do you use the airline? Often the answer is, oh, well, it's just the easy thing to do. They don't understand the impact it can have on equipment. So just as a quick poll, who has seen the operators at their site or site that you've been working at use compressed air to blow down equipment? So just a quick yes, no. So if we could have a quick poll on that, would be excellent. And the poll is being taken now, and we will see just very quickly whether we get a lot of people still out there with compressed air, because I've certainly seen a lot of it in the plants I've been floating around and visiting. So the answer we've got has poll still in progress, but we've got yep, poll's finished. We've got 85% to say yes. So I guess we have that opportunity out there to challenge that practice, but we'll give you a little bit more clues before we actually start challenging the practice. Now, we have a slight challenge on my hands, and that is sorry about that, the screen decided to freeze up on it. Okay, let's move on to the next slide. B, approaches to address equipment failure. What we've done here, we've taken the same slide, but we've added equipment defects in there. Equipment defect is probably the first sign that there's been lack of understanding or desire to care with equipment. And it's an indication that if we don't pick up on the equipment defect, it could lead to early or accelerated deterioration. An example of that might be a build-up of contamination over or around a bearing housing. So if we don't do anything about it, the ingress of the contaminant could get into the bearing. It could be a damaged grease line, that if we don't do something about it, grease will stop moving into our bearing and the bearing could go into accelerated deterioration. It could be nuts and bolts coming loose. So that's sort of the indicator. So if we expand our slide and start looking at how do we approach equipment failures, well, the first one is reactive. People go out there, and when it fails, they get out there very quickly, do a great job, and get it all fixed up. And that could be when the equipment breaks down, or it could be when the equipment starts performing poorly. The other approach is called predictive maintenance. This is where we go out and we use preventive predictive techniques, inspections. We go inspect the equipment if we see it's worn. If it's running hot, for example, we'll organise to replace it before it fails. It could also involve a lot of condition monitoring. So it's trying to find the problem after the accelerated deterioration has occurred and then reacting or fixing it before we get to the poor performance area. Another approach is what we call proactive. And this is where we go out and we start finding the defects and fixing the defects before we get early accelerated deterioration. Often that would involve developing the skills of the operators, because they're the ones with the equipment all the time, and they would be able, we could train them up to go and find those defects, and then we just need a maintenance capability to go and fix them very, very quickly. The fourth way is a learning organisation where we develop the skills of our operators. We give them training in understanding not only how to go and find defects and stop sources of contamination, but most importantly, understand the function of equipment so they can actually pick up on weaknesses in the equipment and do very specific inspections of understanding when something is about to wear, how they should respond to it. So it's developing the operators in not only how to find defects, but how to actually what we call understanding the function of the equipment. So again, just a quick poll. What does your company do? What's your site do? What's their focus in relation to those four approaches? So at your site, you have been working at, what is the main approach to address equipment failures? Is it reactive, or do you put your energies into being predictive? Do you do your main focus is proactive and going out there and getting, some people call it TPM, total productive maintenance, going out and getting operators engaged to find me all the defects? Or you're trying to create a learning organisation where you're putting a lot of effort into the development skill of your operators? Now, in most cases, people are doing all of those four things, but there's often a dominant one you can tell when you go into a site where most of the energy is going. Our poll is progressing, and we are getting some interesting results coming up. Just looking at it at the moment. Again, this just involves your best, I guess, estimate of what you think is happening out there, and what we're trying to do is to give you some feedback as to where everyone is up to out there in the group. So the poll is getting close to being closed, I think. And at the moment, yes, we've closed the poll. And interesting, 42% are reactive and 42% are predictive. Only 8% are into proactive and 8% are into learning. So what does all that mean? Well, I guess the other part to all this is what are the cost implications of these different approaches? And I think there's a lot of literature out there now, but what we've found is reactive improvement is the most expensive way to look after a plant. Predictive is often cheaper. Some people talk about 20 to 30% cheaper if you've got strong predictive maintenance and you're fixing things up before you have breakdowns. However, where the real savings come from is if you can go and find the bent grease line, for example, rather than the failed bearing. Just think about the time it takes to fix a bent grease line and the cost of fixing a bent grease line compared to, say, replacing a bearing assembly in the machinery. And it's when you're in the learning and proactive environment that your costs will come down by more than 50%. And we've certainly seen many examples of that in companies that are embracing this learning and proactive approach. So on the poll, it means about 8% of us are taking advantage of that, and we've got 84% who've got great opportunity to save a lot of money for the company if they can get into proactive and learning approaches to equipment failure. Right, the third point I just wanted to touch on is nature of equipment failure, and this is based on a study that's been done by a number of companies into understanding the nature of equipment failure. Now, when I present this in our workshops, I use the analogy of our motor cars because most of us relate to motor cars, and we think about the reliability of our motor car. The key maintenance strategy that the car companies use when we get our car serviced is a thing called periodic replacement. In other words, we have a service logbook, and in that logbook it will tell us that we should replace certain components at a set interval or set time frame or usage of the car. For example, often they'll say at 40,000 kilometres, throw away your spark plugs, put new ones in. At say 110,000 kilometres, it might be if you've got an overhead camshaft, throw away the camshaft, put a new one in. And the reason the car companies do that is they know that they'll keep the car reliable for you. So periodic replacement is a very good maintenance strategy. What we've found though is when companies have gone out into their own plants and started looking at using periodic replacement, we might have a component that has an average life of 12 months. So we'd say, well, the good thing to do would be let's replace it 11 months so it never fails. However, the studies conducted by companies like DuPont and Alcoa have found when they've gone and looked at a component that say has an average life of 12 months and allowed it to fail and just replaced it year after year after year and recorded at what time interval it actually failed, what you end up with is a distribution. And so 50 years would have 50 points on it, and the average would be 12 months. However, it's got a big tail either side. You've got your worst case scenario, it might fail after 6 months, and on very, very good occasions it might last for 18 months. And if we were to say, right, we will use periodic replacement to replace this component, and we say, right, it fails at 12 months, we will replace it at 11 months, what we find is that on the majority of occasions, probably 60–70% of the time, we'll be fine. We'll replace it before it fails and we won't have any breakdowns. However, for the 30 or 40% on the left-hand side of the interval time, we would have a failure before we got to replace it. Now, typically when that happens in an organisation, especially if that failure does cause production delays, at the morning meeting we will be chastised, bashed up or whatever for allowing the plant to fail if we're maintenance managers, and the maintenance manager might go away and say, well, I better make an adjustment. If the thing failed at 10 months now it caught out, I'll make it now 9 months. And that'll be good for a number of years, but what happens is we'll finally get caught out again. And what we've seen at some sites is they've actually gone back to stop the failures, is that they've found the worst case scenario and they replace the component. Now that's good, no more failures. However, the end result is we have a very expensive maintenance program. So how do we overcome the expensive maintenance program but still get the reliability? Some people will go for what they call PM optimization, which is trying to find a cost, best cost answer between the 6 and the 11 months. We prefer to take the approach that we learned from Dr. Edwards Deming, the quality guru who went from America to Japan to teach them about quality, which ultimately led to the development of the Toyota production system. And Mr. Deming was always on about there's no point improving if you have a lot of variation. You need to reduce your variation. And that was really the focus of these studies by DuPont and Alcoa, etc. How do we understand what's causing this variation? And I'm sure you could all come up with a great list of things that cause variation in component life at your site. What they discovered was that there's 3 dominant factors that made up about 80% of that time. And those 3 dominant factors were things coming loose, contamination getting into equipment, and lubrication not being perfect. And a term came up that relates to this called basic equipment conditions. So to have basic equipment conditions, you have no looseness, no contamination, and perfect lubrication. And what they found is if you went out and achieved that, and often looseness is another name for defects, things aren't right, getting the looseness, contamination, and lubrication right, you'll actually squash up the curve because you'll take out the variation. Now that frees up time for your maintenance resources, it stabilizes your plant, and what it also allows you to do is once you get past this I guess reactive stage of responding to all these things with their variation in component life, is to start looking at design weaknesses. Where is the weaknesses in our plant? Again, use a car example. I remember an old car I had many years ago. We had a distributor with a set of points in it that would run spark up to the spark plugs to run the engine. Now, what we found is the points used to wear quite often, and you'd have to re-file them, and that would put the timing out, so you'd have to continually adjust the timing on the car. Quite a heavy maintenance activity. This day and age, they've identified that design weakness and they've gone and replaced it with electronic ignition, so you now have a little black box that doesn't need any maintenance and it lasts for a hell of a long time before it needs replacement. So that's what we call design weaknesses. In most of our plants, we don't have brand new equipment, so when we go out there and look at it, there's probably a lot of components that could be replaced with better design components. Unfortunately, we often don't get the time to do that. If we can get the basic equipment conditions right, we can then start working on the design weaknesses. And I guess our learning has been the people who know where the weaknesses are in the equipment are the people who operate the equipment. So it's again, if we can develop their skills to understand the functioning of equipment, they can help identify these design weaknesses. And the end result is we substantially save money. And again, at least 50% reduction in our maintenance materials costs. So that's a bit of background. Let's get on to what we want to talk about. Operator impact. Do operators have an impact on equipment performance? Well, let's look at the role of the operator. We want them to achieve the production plan, obviously. Now, in this day and age, obviously they have to be also very good at frontline safety and environment. They're the front line. If there's any hazards out there, we want them to respond straight away, whether it be a hazard to safety or a hazard to the environment. And in fact, most best practice companies now have their operators involved in checking on the behaviours of their colleagues to make sure that everyone's behaving, got good safety and environmental behaviours. Frontline quality, we expect our operators in this day and age to pick up on quality problems at the earliest possible time. If we want perfect equipment and perfect performance out of our equipment, we need to make sure our quality is right. And that quality is not just what we make, but the materials we're using to make it, what we call zero defects accepted. Don't accept bad packaging material, don't accept bad raw material. Pick it up before we start processing it is very, very important. Obviously, processing it correctly is very important, and thirdly, making sure what we do finish up with is correct. Energy management is becoming very, very important, so being able to pick up on any energy losses at the earliest point is a very important role. And then comes frontline equipment care. That's what we've been talking about. So you've got all these other things we want operators to do, but then we want them to take care of the equipment. And finally, formal ongoing improvement. We want them to be involved in improvement activities as well. So if our operators are capable of doing all that and we have trained and developed them, we have a hope of getting perfect equipment performance. If we don't develop our operators and just bring them in, give them a few standard operating procedures and tell them to go to it, I assure you your equipment will not perform very well and you'll have very high costs. The other myth is maintenance. What's about maintenance impact on all this? A lot of organisations you go to, they think, well, you know, operate, maintenance, maintain, you operate, you fix, etc. We've found the whole thing is a very integrated activity these days if we want to get up to a learning and proactive environment. Obviously, the operators have to do the frontline equipment care. They're the ones out there with the equipment to find the defects at the earliest possible time. Maintenance still need to do their repairs, they need to do their preventive predictive maintenance, monitor the equipment, etc. And most importantly, the strategic maintenance, design out the problems and standardise. By standardising, we mean we want to teach operators about equipment care, about lubrication, about components. If we can standardise a plant, it becomes so much easier for them to learn and therefore be more effective in taking care of the equipment and identifying problems at the earliest possible time so maintenance can get out there and do a good job. So maintenance role in all this is not just go out there and look after the equipment, but learn to become great teachers at teaching operators how to take care of the equipment. And the third myth or third item we want to talk about is planning and scheduling. You can go out there and train all the operators in how to take care of the equipment and you can have brilliant maintenance people. But if you have a production plan that gets swapped and changed all the time and you can't have regular activity to learn how to care for the equipment and do the regular maintenance, and often we want to get to what we call synchronous maintenance, where we're bringing operators and maintenance working together in synchronous fashion to get the best performance out of the equipment. So the questions we ask people are daily or weekly production plans ever changed after being issued? Are planned maintenance activities deferred during the week at the last minute? or firefighting being an appropriate term to describe the way things are sometimes done. If you've got that challenge, you've got to address it. And there's ways of addressing that, of course. But if we don't address it and get a stabilised production plan, you're just not going to get into this learning and productive environment. So I guess what we've concluded from all this is that to minimise costs, we need to address equipment problems at the source, fix damaged grease lines rather than failed bearings, as I've been talking about. So we need to train operators to know what to look for and change the equipment so it's easy for operators to find the problems. We need to create a maintenance support capability that can respond to small problems and issues identified by the operators. In other words, if an operator goes out and finds a defect and tags it and says, oh, I found something wrong, and nothing happens because it goes into the convoluted work order system for weeks, the operators aren't going to be motivated to go and find more problems. And we need to stabilise our production plan so there's regular time for equipment care activities so we can synchronise our maintenance activities with the operator care activities so we can minimise our planned maintenance downtime and have it in small doses. Instead of having a shutdown once a month, 2 hours every week doing our preventive predictive maintenance and our equipment care activities. So going forward, how do we do all this? Our learning has been we need to get the decision makers and key employees on the same page through education and training. So everyone needs to understand some of these issues with getting equipment running perfectly. We always suggest that you set up a site leadership team to develop an agreed way forward, and we use 12 to 14 week cycles of ongoing improvement. It is better to do a small bit of training every week and have a set program time. If you go on the web and look for a diet program, a training program, you'll often see it's all based around 12 weeks because that's the physiology of human beings. We like 12-week programs, and we can put our head around them and we can get very good results. So we start with a few cross-functional teams to in significant pilot areas to understand and address equipment and process losses. Once gains are achieved, we introduce production area-based teams to sort out their work area, then care for their equipment. So we want them to focus on defects, then focus on contamination, then focus on lubrication, then focus on functioning of equipment. And then we cascade this across the site at a rate that supports your business plan. In other words, how urgently do we need to get these cost savings? How urgently do we need to get our equipment working perfectly? How urgently do we need to develop our people? And our constraints are often our facilitation resources and our support constraints, ability to go and fix up things. So we need to address those issues as well. Now, we have a paper called Getting TPM and Lean to Work Using a TPM Approach. This is a paper we issue at our, we run 2-day workshops throughout Australia, which gives you a strategic overview and the detail of how to make what I've been talking about very, very effective and successful in your organisation. So the paper is a bit of a summary of all that. So that is available on our webpage, and you're most welcome to go to our webpage and download a copy of the paper. With that in mind, I will move back to Samantha for question time. Thank you very much.
Thank you, Ross. Thank you for that very insightful presentation. So this is the time that you can have questions. So if anyone has any questions, please type them in your control panel provided. While we're waiting, Ross, I've got a question for you. How do you engage your operators to do all this? It sounds like a lot more work for them. I can just see the faces now when you actually tell them about it. So how do you actually engage them?
Good question there, Samantha. Yeah, what we find is when we look at operators and they think, well, I just come to work and I'm employed to operate the machine, and they want me to go and find defects and whatever. I guess the thing we've learned is that the Australian workforce, or Australasian workforce, Australia, New Zealand, the workforce is one of its unique characteristics is it's very much driven by what's in it for me. Most of our workforce tend to, every time management try to introduce something new, it's all about what's in it for me. And the thing we've discovered is that if we go and ask our workforce the question, do you ever get frustrated because the equipment is not working perfectly? Most people will nod their head and say yes, whether that be the operator, the maintainer, the planner, or the supervisor. So going into the workplace and saying, hey, we want to start some initiative to get the equipment to work perfectly, we find gets very quick buy-in from the operators and the maintainers.
Okay, great. Okay, just looking at your other questions. There's no more other questions. There is one just saying, is the PowerPoint presentation available for members for internal use? This PowerPoint presentation will be, this webinar will be uploaded to our YouTube channel. As for the actual PowerPoint presentation, Ross?
For our CTPM members, we'll make it available.
Okay.
For company members. So, again, benefit of being a CTPM company member, we'll give you a copy of the PowerPoint presentation so you can use it in your own workplace.
Excellent. So if you'd like to learn about membership, you can go to our website as well. You can become individual members and also company members. It describes it that, or you can just give us a ring and we can tell you about it. Okay, so there's no more other questions, so I'll just move on because I know everyone is busy. A special offer. So a webinar's nothing without a special offer, of course. So we've got a discount happening. So if you're actually interested in what Ross has been talking about today and would like to learn more, we've got our 2-day Getting TPM and Lean to Work workshop. This workshop provides a detailed pathway of how to get equipment and people to work perfectly at the lowest possible cost. So we actually have a special discount on that just for 24 hours, 20%. So if you're interested in attending with this discount, if you've got a registration form, just send it in to us with a note saying webinar discount. If you don't, contact us and we'll send you a brochure with the registration form on it. We have 3 workshops happening. We have one in Auckland on the 4th and 5th of March. We have one in Melbourne on the 19th and 20th of March. And we also have one in Sydney on the 14th and 15th of April. Other than that, we have our next webinar coming up next month on Wednesday the 13th of March, and it will be engaging your people in team-based improvement. So hopefully you'll be able to make that one as well. And if you have any other questions, or if you need more information, or if you just like to ring up and have a chat, feel free to contact us at any time. So thank you for attending, and we hope to see you next time. Any other comments, Ross, before we go?
No, thank you very much, Samantha, and yeah, thank you for listening to our webinar. And, good luck on your journey to get your equipment and people working perfectly at the lowest possible cost.
Fantastic.
Cheers.
See you next time.